Let's review logarithms, and let's start with logarithms to the base 10. The fundamental property of logarithms is that they solve this equation. If you want x equals 10 to the y and you want to know what y is log base 10 of x. This holds as long as x is greater than 0. From this relationship, we get two very, very important equations. One says that log base 10 of 10 to the x is equal to x. We get that by just putting in 10 to the y over here, and we have log base 10 of 10 to the y is equal to y. Instead of y, we usually write x. The other important equation is 10 to the log base 10 of x is equal to x, as long as x is greater than 0. And to get that one, all we do is we take this y equals log base 10 of x, and we put it in over here for y. And we have 10 to the log base 10 of x is equal to x. What these two equations say is that 10 to the x and log base 10 of x are inverse functions. They undo each other. Log base 10 of 10 to the x log base 10 undoes 10 to the x, and we're just left with x. And 10 to a power undoes log base 10 of x, and we're just left with x. This is the property of inverse functions. And this is the defining characteristic of inverse functions, where we go from a function to its inverse. So let's look at some examples of how we can use these properties to simplify expressions and solve equations. Suppose we want to find log base 10 of 10 to the 5th. Well, that fits this rule perfectly. If we see log base 10 of 10 to the anything, we know the answer is just going to be that 5. Similarly, if we have 10 to the log base 10 of 23, that fits this rule perfectly. If we have 10 to the log base 10 of anything, we're just going to end up with that anything, so the answer is just 23. Now let's see if we can't figure out what log base 10 of 1 is, and we'll do this in a couple ways. One way is we'll go to this first top property here and try to figure it out from that. We've got log base 10 of 1, so x is 1. So over here we can put x equals 1, and we say 1 equals 10 to the y, and we can ask what y should we use to solve this equation if we want 10 to the y to equal 1. Well, 10 to the 1 is equal to 10. That's not going to work. But if we remember 10 raised to the 0, or anything raised to the 0, any non-zero thing raised to the 0 is going to give us 1 back. So that suggests that the answer is 0, and that's in fact correct. So one way of solving for log base 10 of 1 is just put 1 right here, 1 equals 10 to the y, and see if we can figure out what y is. In the special case of 1, we could figure it out. In most cases, we would need a calculator to estimate the value. But there's another way of doing this, and that's just writing 1 as 10 to the 0. So if we think about this rule, we could take that 1 and write it as 10 to the 0. That's essentially the same thing that we did up here. And then we have log base 10 of 10 to the 0, and of course, by this rule, that'll just be 0. Let's look at another one. Suppose we want log base 10 of 10. Well, for log base 10 of 10, we put a 10 here, and we say we want to solve 10 equals 10 to the y. What should y be? Well, it's pretty clear that's equal to 1. We could also do the same problem by saying this is log base 10 of 10 to the 1, and we just get 1 back. These are important properties that you have to remember. Log base 10 of 1 is always 0. Log base 10 of 10 is always 1. You need to commit those to memory. Similar things hold for other logarithms. We can say more at this stage. We get an estimate on how big things are. Log base 10 is 1, and log base 10 of 10, log base 10 of 1 is 0. Log base 10 of 10 is 1. So for x is between 1 and 10, log base 10 of x is between 1 and 0. It's increasing. So log base 10 of x isn't very big. It doesn't grow very rapidly. If x is between 1 and 10, log base 10 of x stays between 0 and 1. That's a useful way of estimating things. Let's look at another example where we have to solve for x. Here we're supposed to solve for x if 10 to the x is equal to 3. It's a simple procedure to remember that when you have 10 to some power or something to some power, you take logs of both sides. In this case, since 10 is the base, we take log base 10 of both sides. Log base 10 of 10 to the x is equal to log base 10 of 3. We just apply log base 10 here and log base 10 here. And now we use this rule. Log base 10 of 10 to the x is equal to x. So on this side of the equation, these are inverse functions. They undo each other, and we just have x. X equals log base 10 of 3. And that's the answer. That's how you solve this for x. We could have also done it directly from here. We have 10 to the x is equal to 3. That says log base 10 of 3 is equal to x. So we could have solved that equation directly by using this property. Here's another one. Log base 10 of x is equal to 52 for x. You could solve it from here. You have log base 10 of x is equal to 52. Y is 52. so x equals 10 to the 52. Or we could take both sides and use them as an exponent with the base 10. So 10 to the log base 10x equals 10 to the 52. And again, by this property, 10 to the log base 10x undoes each other. And we have x equals 10 to the 52. This is just a brief review of the way logarithms work as how log base 10 works as an inverse function of 10 to the power.